So today we are gonna discuss about building a complete RPG game. So in this topic, we will learn how to combine all the concepts and techniques from earlier topics to create a playable and complete game. So this is like a building a puzzle where each piece represents a feature or functionality you've previously worked on. So first, uh, we'll discuss about assembling game components. So what this means is basically bringing together all the parts of your game, characters, enemies, environments, UIs, scripts, and integrating them into single project. So how it's done, basically reuse assets and scripts from earlier topics such as movement mechanics, enemy behaviors, UI elements, and combine these elements into modular way so each part can work independently but also interact seamlessly with others. Like for example, the character uses the movement script while the enemy follow their AI behavior script, and both interact with the environment. And the other topic is point and click movement controls. So players control the game by clicking with their mouse instead of using keyboard or joystick. How it works is basically players click on the screen to move their character or interact with objects. The technical approach for this is Unity's raycasting feature detects where on the game world the player clicked. For example, if a player clicks the ground, the character moves to that spot. So if the player clicks an object, the character interacts with it. So why it's important? Because point and click controls are intuitive and widely used in games like action RPGs or adventure games. And the other topic we're going to discuss is upgrading the user interface. So basically it's about making your UI more interactive and useful for adding elements like screens, health bars, menus. So how it's improved is you'll be adding an inventory system that allows players to see and manage collected items, and you'll also display game status indicators like health, energy, or score to keep players informed, and create interactive menus for game settings or pausing the game, and also use Unity's canvas system to build and position these UI elements. And the other topic we are going to discuss about is dynamic level loading. So what this means is transitioning smoothly between different game levels or scenes as the game progresses. How it works is you can use the you will use the Unity's scene management system to load new levels when players reach specific points like an exit, or and keep track of players progress such as inventory or stats, so it's carried over to the next level, and also add effects like fade ins and fade outs to make the transitions look smooth and professional. And the other topic is win and loss conditions. So it's about setting up rules for when the player wins or loses the game. How it's done is you define the conditions for victory. For example, reaching a goal, collecting all the items, and loss is basically running out of health or time. So you will create a logic to check these conditions during gameplay, and you'll display appropriate messages like game over or you win when the conditions are met. And the other topic is persistence game states. So what this means is it allows allowing players to save their progress and resume the game later. How it works is you basically save important data like player position, inventory, level progress, to a file or a database and load this data when player resumes the game to restore their progress. For example, if a player quits the game after reaching level 2 with 3 collected items, they should start exactly there when they return. And we'll also discuss about comprehensive features like building a demo game with various elements to make it engaging and complete. So some of the key features is top-down view, a camera angle that allows players to see the game from above, which is ideal for point and click controls. Another feature is interactive devices, objects in the game that players can interact with, like switches or doors, and collectible items that players can pick up and use, such as keys or potions. And the other feature is inventory system, UI elements where players can view and manage their collected items. And other feature is AI controlled enemies, enemies that move or attack based on simple AI behavior, and multiple levels. So different areas or stages with unique challenges and objectives. So how it's built is you'll start by planning the game structure, decide what elements you need and how they will work together, and add one feature at a time, testing it thoroughly before moving to the next feature, and reuse the scripts assets from earlier projects used to save time and maintain consistency. And make sure you focus on modular design. Each component should like for example each component for example player controls, UI, enemies should be self-contained and easy to update or replace. Like for example, inventory system works independently of the level loading system, so changes to one won't break the other. um, so by end of this topic, you should have a fully functional action RPG game prototype, and a top-down view with point and click controls, and dynamic levels, AI enemies, interactive devices, and an inventory system, and persistent save load functionality. So this topic demonstrates how to take a collection of individual features and assemble them into a cohesive game. It highlights the importance of planning, modular design, testing to build a uh, polished game. So first is building a complete AI action RPG game. So this topic is accumulation of all the concept learned throughout the from throughout the throughout this course, integrating individual game elements into a fully functioning action RPG. So this topic focuses on applying previously acquired skills in a practical way, resulting in a comprehensive game project. So assembling game components. So the project builds on the foundation created in the previous topic, which includes character with animations, third person camera which follows the character dynamically as they navigate the scene, and interactive devices, objects like switches, doors that can be operated by the player, and the manager framework, backend scripts which that handle essential game systems such as inventory and game states. So there are a few enhancements that we will be doing. Elements from other topics are integrated to expand the functionality. For example, AI enemies and inventory system management systems are added to create a richer gameplay experience. And upgrading the manager framework. So the manager systems which we discussed in earlier topics is updated to incorporate features from from chapter 10, I think. So, although not actively used in this topic, it is added to make the game's backend ready for online functionality, such as fetching data from a server. This ensures that all game manager starts with necessary infrastructure for future scalability. So, and integrating AI enemies. So AI enemies are incorporated to provide a challenges and interactivity in the game. So the key components are here are wandering AI, which handles random movement of enemies within the environment, and reactive target is which governs enemy reactions, such as how they respond to being attacked, and will also add a fireball, which manages projectiles launching by enemies. So uh, scripts and assets are important into the project, should be imported into the project, and prefabs are linked to their respective Unity scripts in Unity to ensure proper functionality. And then implementing the point and click controls. So the game transitions from a third person control system to a point and click control scheme, which is common in action RPGs. So how it works is players click on the ground to move the character to the clicked location, and clicking on objects or enemies triggers interactions or attacks. So this control scheme is intuitive in our for RPGs and enhances strategic gameplay by simplifying movement and interaction. So the scene controller script, that script manages enemy swanning and behavior, ensuring that they appear correctly in the game. And inventory management, which is updated to align with the expanded framework, maintaining compatibility with the network service and other components. So this topic is important step in understanding how to combine various game elements into a unified project, and update and enhance frameworks for scalability and future features. And you'll also implement AI and user-friendly control schemes tailored to the journey. So the project not only reinforces modular design and code reusability, but also prepares you to handle complexities of building feature rich game. By end of this topic, you will have a developed fully functional prototype of action RPG. Uh, so next is creating an action RPG. So this section focuses on building an action RPG with top-down view and point and click controls. So the topic adapts components from earlier projects to create a intuitive gameplay and interaction, also highlighting how the use of Unity's tools for game development. So first is adjusting the camera for top-down gameplay. So the game uses top-down view, which is commonly found in the action RPGs. This involves placing the camera higher and angle to view the game scene from above. We'll also modify the orbit camera script. So to simplify gameplay, the camera no longer rotates freely with the mouse. So arrow keys control the camera's horizontal rotation around the player, and the orbit camera script ensures the camera always follows the player's position, creating a stable view. So let's go to the orbit camera. So here rot y, which keeps track of camera's horizontal rotation, and transformed at position. So transformed out position ensures the camera maintains the fixed distance between the offset, uh, which is the offset from the player, And transform dot uh, look at target makes the camera face the player. So players move the character by clicking on the terrain, and a raycast is used to detect the clicked position, setting it as the target distance. And point and click movement script. So this script handles mouse movement to move the character. It detects terrain clicks and smoothly moves the character towards the target position. Uh, so here this line detects this line detects left mouse button click, and ray this line creates a ray from the camera to the click position, and this line checks if the ray hits an object, and target position mouse hit dot point, uh, this sets the clicked position as the target, and here starts moving the character. So the key features is the ray determines where the player clicked on the terrain, and the character moves smoothly towards the target position, and slows down as it gets slower. And animator, so somewhere here there should be animator dot set float speed, which not able to find it here, but it basically adjusts the animation to match the movement speed. And next is making devices interactive. So devices like color changing monitor can now be operated by clicking on them. So the base device script, the script handles device interactions, like ensures the player is close enough, checks if the player is facing the device. And the key points in this code is vector 3 dot distance checks the proximity to the device, and vector 3 dot ensures the player is facing the device. And the operate method is virtual, allowing different devices to define their specific behaviors. So next would be adjusting scripts for compatibility, like to avoid conflicts between movement and device clicks. Layer based checks ensures actions are directed to the appropriate objects. Uh, Basically, this ensures making adjusting scripts ensures clicking on devices triggers interactions, clicking on terrain moves the character. So the key features implemented here is a top-down camera optimized for RPG gameplay, intuitive point and click movement using raycast, and interact devices that responds to mouse clicks. What's achieved here is the game now feels more like a action RPG with smooth camera behavior, intuitive controls, and enhanced interactivity. So this topic highlights how to adapt and integrate existing components to fit a new genre. It demonstrates Unity's flexibility in transforming gameplay mechanics while maintaining modular and reusable code base. So next topic is upgrading UI. So in this topic we focus on enhancing the game's user interface by transitioning from UI Unity's older GUI system to the modern flexible UI system, which is introduced in previous topics. This upgrade provides a more visually appealing, dynamic and interactive UI elements experience for the players, aligning with the industry standards for game design. So setting up the new GUI, first step is creating a foundation for the new UI system. So this involves importing assets, designing a canvas, and adding interactive elements. So first, importing UI graphics. So import UI images into Unity. For example, you can use pop-up uh, for an inventory, or a pop-up window. So, and adjust the graphics using the Unity's sprite editor to ensure proper scaling for different screen resolutions, and creating a canvas. So a canvas is required to hold all UI elements in, like buttons, text, images. So to create one, you can go to game object UI and canvas. You'll find canvas in Unity. So the canvas acts as a parent object for all the UI components, ensuring they scale and position correctly on different devices. And you can also add text for displaying health or other game information. And programming the UI. So to make UI dynamic and responsive to game events, we use the messenger system to introduced earlier for event handling. So the messenger script. So the messenger script from earlier topic helps different parts of the game communicate effectively without being tightly coupled. So we add an event for health updates in the game event script. It's not, but yeah, you'll add an event for health updates in the game event script, and in the player manager, you can in the player manager broadcast a health update whenever the player's health changes. Think yeah, this line. So this we'll be adding this part of the code, and what else? Also, you'll create a script to listen for the health underscore update this event, and update the health label. And so next step would be implementing the inventory system. So the inventory system displays the player's collected items in a pop-up window with icons and labels. So to dynamically update the inventory UI, you create UI elements like adding placeholders for icons and labels in the pop-up window, and you write a script for dynamic content, which will populate the inventory UI based on the player's items. Uh, and then linking the UI elements. So you connect the buttons and sliders to their respective functions using Unity's inspector. For example, you attach the on health updated method to health related events, and also link the pop-up toggle method to the inventory button, uh, and also make sure the health label updates when the player health changes, and also check that the inventory pop-up toggles correctly and dynamically updates its content. So the upgraded UI system introduces a more interactive and user-friendly interface. So by using the messenger system and event-driven structure architecture, UI dynamically responds to the game changes, and players experience a polished interface that enhances usability. So this implementation not only explains Unity's advanced UI capabilities, but also showcases how to integrate a flexible, dynamic, and visually appealing interface into our game. So I didn't go in depth because it's all about bringing assets, scripts together. So it should not be that difficult, because you have everything together. So it's just so we'll So we'll discuss the rest of the topics in the next session.